Welcome to the eCave. In this episode, I'll be tackling one of the first PS2 machines I have in my collection. The objective is to look at some of the diskette drives and fix them up. So if you're interested in that, please join me. Well, thanks for coming in today. As I mentioned in my last episode, I was worried about the fact that a lot of the PS2 diskette drives in the PS2 machines I've got have self-exploding capacitors that tend to bleed all over the PCBs and over time destroy them. So I've looked at my vintage computer collection, and as it turns out, I've got 18 PS2 machines and 2 PS1 machines. So I can't defer this any longer. Time is the enemy. So it's time to begin the process of restoring these diskette drives. Now, I obviously can't restore everything, all the PS2 machines, but at least I have to start. So where better to start than a PS2 Model 30 machine? I've got one here lined up with a 12-inch 8512 color monitor and a Model M2 keyboard. So, but wait, there's more. I've got 2 more PS30s waiting in the wings as well. At least I can take the diskette drives out of those and test in this machine. It would also be interesting to see if I can put a compact flash card light into a PS30 machine and see if that works as well if the hard drives are not operational. But first, let me show you the machine I have, and then I'll tell you a bit about the PS2 background and history from an IBM perspective. Yes, I used to work for IBM, and I was, of course, working for IBM when they announced the PS2 machines. But let's start with exploring this machine on the outside. I guess I have to start with the monitor. I don't want it to explode when I power it on, and then we'll have to look at the machine. So let's look at it first. Here is the monitor, 8512 12-inch color monitor. I've no idea if it works. We'll have to check that out. As I said first, this is a PS2 Model 30 286, and I'll tell you a bit more about that. And here's the M2 keyboard. It looks a bit flat, but you may notice I've got a bit of a bag here, and that's 101 buckle springs. So when I got this, somebody had disassembled it, but thankfully kept all the buckle springs. So we may have to use a more modern keyboard in the interim. It will take a while to get that together. But the PS30 looks a bit dirty. And here at the back, I can't see any other cards in it. But the monitor is also a bit dirty. So we'll have to clean it up. The other two, who knows what's inside of these? I'll throw off the model numbers because some of these model numbers can be difficult to find. However, somewhere on Ardent Tools, the website, which I'll link to, is an article about how to decode the model numbers. And that might help people if they have a model number they can't find. So I'll put that up as well and link to that. Now, let me first tell you a bit about these machines and when they were launched. And then we'll get stuck into opening up the monitor. Before talking about the PS2 line of computers, it's worth remembering that IBM had released the IBM PC AT Model 339 in April 1986. It was a faster version of the original IBM PC AT, originally announced in August 1984, because the AT339 had an 8 MHz clock instead of the original 6 MHz clock. Now, when IBM designed the IBM PC AT, they expanded the 8-bit bus to a 16-bit bus, making sure it was backwards compatible with the previous 8-bit ISA-bus. The AT machine was immensely popular with IBM's customers. Now, the biggest number of the IBM PCs, XTs, and AT computers were sold to businesses, both small, medium, and large. These were the customers IBM designed the PC for. They were never meant for what we call today the home market. The medium to large businesses used these machines to replace dumb terminals because they gave the users far greater flexibility than the dumb terminals could. Through them, you could access the bigger systems via terminal emulation, but on top of that, you could run other productivity software. Not only that, the emulation software evolved to allow you to access mainframe data very seamlessly, and having that ability made it easy to incorporate mainframe data into other applications on the PC. After the release of the IBM PC XT and later the AT, what IBM began to realize was the fact that the PC architecture was limited in a number of ways, given how their customers were using the personal computers. The PC with a DOS operating system was not originally designed for multitasking. It was a single-threading operating system. It therefore made it more difficult to run multiple applications concurrently on the PCs. The scalability of the PC architecture, which had evolved to a 16-bit ISA bus, was quite limited, and then on top of that, the physical size of the machine was way too big. You just have to look at an IBM AT beside a PS2 machine to see the difference. IBM then decided to embark on a project to revamp the architecture of the IBM PC line of computers. The issues they were wanting to solve were things like the physical size of the machines by making them smaller and more ergonomic, the ability to endow them with more memory so they could increase the memory to allow multitasking. They wanted to go from single tasking to multitasking so users could run multiple applications concurrently in a more seamless fashion. They wanted to increase the size of the data bus to allow for higher throughput and more memory. They wanted to change the bus architecture to allow for higher clock speeds, reduce the EMC interference, lower the physical force required to insert these cards, and increase the number of bus lanes. They wanted to avoid customers having to physically configure cards via diff switches, to automating the process of configuring the PC through software. They wanted to reduce the amount of cards a PC would need to operate by incorporating standard options like display controllers, parallel and serial ports, diskette and hard drive controllers into the motherboard itself. They also wanted to enhance the display capabilities of the machines to show more colors and clearer text. They wanted to engineer the machine for greater reliability, resulting in reduced cost for service and downtime. Now, all of these requirements led to the introduction of the microchannel architecture, along with many other changes, which eventuated in IBM's announcement on the 2nd of April in 1987. This is when 3 new machines were announced. The Model 8530, which used an 8086 processor, and the 8-bit ISOBUS, plus 2 new microchannel-based machines, the Model 50 and the Model 60. Now, apart from the microchannel bus, IBM introduced around 200 additional products, many of them which was related to the new architecture, which they chose to call Personal Systems 2. They included new technologies like the new VGA display standard, new bidirectional parallel printer ports, faster serial ports, memory SIM slots, the PS2 mouse port, a mouse, and they standardized on the 3.5-inch diskette drive. Now, along with the technology changes, they also released a number of new microchannel cards for the new microchannel models, new versions of various software to take advantage of the new technology, plus also a new multitasking operating system they called OS2. Of course, IBM had to have a new name for all of this, so they called it Personal System 2. This was a very clever way to differentiate not only from their own personal computers, but also from all the clone makers. What I've always found interesting is the fact that when IBM released the original IBM PC with the 8-bit ISOBUS, the clone makers happily adopted it and made their clones identical. The same thing occurred when IBM released the PC-AT with the new enhanced 16-bit ISOBUS. It was of course quickly adopted, and all the clone makers fell over themselves to produce clones with the same bus architecture using the same technologies as IBM. Now, suddenly when IBM released the microchannel bus, the clone makers didn't like it and began accusing IBM of using proprietary architecture. My belief is that it had much more to do with the fact that with the ISOBUS, they got a free ride, i.e. they didn't have to pay any licensing fees to IBM and could simply clone the ISA architecture and profit from it by making their own computers at a lower price. When it came to the microchannel architecture, IBM had enough and decided they would require clone makers to pay a license fee if they wanted to make microchannel clones or microchannel cards. The clone makers didn't like having to share any profits with IBM, so they of course ended up going their own way by extending the IBM designed ISOBUS into the EasyBus. That way they could avoid having to pay IBM any royalties. I also believe IBM made a big mistake by setting the licensing fees for the microchannel architecture far too high. They perhaps did that on purpose, which in the end made them non-competitive and became the death of microchannel. I think the important takeaway here is the fact that IBM didn't architect and design the personal computer or the personal systems for the home market. These machine designs were primarily driven by the need of their customers, using mainframes or mid-range systems all the way down to small businesses. For example, soon after IBM released the first 3 PS2 machines, one of the airlines in America ordered 50,000 Model 50 microchannel machines So they could replace their old dumb terminals throughout their whole distribution network. As I mentioned, I do have a number of PS2 machines in my collection. Of the first 3 PS2 models released in April 1987, the only one I have which dates from that time is a PS2 Model 60 microchannel machines. I do have a Model 50Z which came just over a year later with an updated motherboard to accommodate more onboard memory from 1 megabyte to 2 megabytes. Otherwise, it's almost identical to the original Model 50. Now, the 3 Model 30 machines we have here are the updated version of the Model 30, released about a year and a half later. Instead of having the 8086 processor, the new version was based on the 8086 CPU, plus they upgraded the onboard display adapter from the MCGA standard to the new VGA standard, plus gave them the 60-bit ISA bus as well, as was appropriate for the CPU. Well, I'll better stop myself here before I go off the deep end on the history of the personal systems too. But I think it's time to focus on the Model 8530 to 86 and try to get that operational so I can work on the diskette drives. Now, I've decided on reflection not to tackle the 8512 14-inch color monitor. I think that's an episode in itself. However, I was lucky enough to score a slightly more modern LCD monitor with a model number 9512, which is 14-inch as well. And you can see that here. And it's beige. It's actually very rare to get beige monitors from IBM. Now, I didn't get a base for it. However, what I did find out was that some of the other monitors I have from IBM, which are 15 to 19 inch, the bases on them do work on this one, but they're all black. And now you can't have a black monitor on a stand on a beige monitor. That's sacrilege. So I painted it. So I'll show you some photos. And I think it comes out pretty good. It looks almost original, although I've actually found the original monitor stand for this because it's made by LG. And it's an LG part number, and hopefully it's beige as well. So I'll see what I get in the post when I finally get it. But my idea was to actually paint the other IBM monitors in similar colors, sort of make them period correct, because monitors like the 8512 are not going to last very long. These are CRT monitors. They're on borrowed time. But anyway, I'll take the monitor off and open the cover and show you inside before we power anything on, that is, to see if there's any magic smoke coming out of it. So let's open it up and look inside. So let's take this monitor and put it aside here. And take the cover off. Put it over here. And then I'll show you what's inside here. Jesus, that's pretty dusty, I must say. Well, you'll see. Here it is in all its glory. And you can see it's pretty dusty. It's layered with years of dust. There are no ISA cards in there, but you can see it has a real-time clock chip, a Dallas one, which I'm guessing is non-functional. Now, the rest of it is a bit dirty as well. We have a hard drive and a floppy disk drive. And that looks like a tech model. But anyway, I can't see any juices flowing out of it, so hopefully it is okay, but it's pretty bad dust. The power supply is full of dust. Now I pulled out a Model M keyboard, which is a bit frayed. I hope it works, so we'll find out. At least the monitor looks a bit spiffy. And I'll try to capture everything that comes out of it. I've got a VGA splitter cable here. One goes to the monitor over there, and the other one goes to the capture device. So if anything comes out of it, I'll be able to see it on the computer and capture it. Not bad. Let's set it up and fire it on, or see the fire come out of it, whichever way it works. Well, as you see, I'm ready here to fire it up for the first time, or put it on fire, whichever happens. I've verified the AC cords are powered in, and you can see the monitor is on. I'm also capturing on the screen. So let's hope for the best. All right, we're getting one long and two shorts. And we're getting a memory count up. I'll show you on the screen. Lots of errors. 161, 2401 and 601. So we're in for a bit of a diagnostics. So we'll have to decode these errors first, but I suspect time is one of them, and I think the Dulles chip has a problem. So I might swap it out with another one I've modified. It's probably in one of these. I'll try to find it and put it in there, and we'll try to power on again. I've taken the old one out and put a modified one. I'll show you a photo of it up here. But it measures just over 3 volts, so the battery seems to be okay. It should work. I've also put in a PS 286 reference diskette here. So let's try, see if it fires up. Yeah, still not happy, which I expected. Counting up memory. 2401. I'm guessing it's a hard drive error. But 601. What next? Are you just going to give up? Are you going to try the diskette? Come. You're a 286, you can do things. Well, it seems to get stuck here. I'll wait and see if it does anything more, but I'll come back if it does. But I'll stop for now. That's the hard drive error, 1701. I'm not sure what 2401 is then. 162. See, it took my encouragement. Press F1. Yeah, I think we need to do something, because it's not happy. Not even sure what this 2401 error is. I've got to look that up. Could be the keyboard though. Let me see, do we have anything? Yeah, num lock comes on. Caps lock and scroll lock, so that tells me the keyboard seems to be talking to the system unit. But there's definitely something amiss when it comes to the motherboard. It's not happy and it doesn't like the diskette drive, so I'll have to look at that. I've just taken out the riser board and the clip that holds it, so it's easier to measure. I'm going to check the power supply. The 2401 error points to the monitor or the motherboard. So I've connected the monitor directly, not via the split cable. And once I did that, it just powers on and nothing happens. No beeps, no errors on the screen, nothing. So I've got the ground here, and on the power supply there's a handy chart. I'll show you in the photo. So let's measure the voltages on the power supply. The first pin is what's called power good. That's 5.14 volts. That may be good. I've got to check what that is supposed to be. Next we have a ground point and then plus 12 volts, which is 12.141. Then we have a minus 12 volts. I'm just trying to get access to this. Minus 11.7. That looks good. Then it's all ground until we have the minus 5 volts. What's this? Minus 4.9, that's good. And then I'm guessing the next three are plus 5 volts. Yep. So that's all good. Plus 5, plus 5. And the last three on the second plug would be plus 5 as well. Plus 5, plus 5, and plus 5. So the voltages are good. So what I'll do, I'll take it apart, clean up the motherboard, have a look inside the power supply, and look at the diskette drive, and I'll show you what I discover along the way. I managed to pull this system apart. Getting the covers from the drives is a bit of a delicate process, so you don't break the tabs here, but I did manage that. The drive and the diskette drive simply slide out once you unlatch these hooks here at the front. That's the easy bit. The power supply, there's only two screws, one here and one actually here on the side. Once they're out, that slides towards the front and pops out. Obviously you have to disconnect it from the board. Now the cable come out easy. The VGA cable here has to be unscrewed from the side, but that's straightforward and easy. The motherboard has a number of screws. If you're only doing the motherboard, you can actually undo all the connectors on it and undo the screws, and it will come out without having to take the front or the sled for the drives off. Getting that off and this is not a simple exercise. Now I decided to do that because you can see here, let me show you if the camera does focus on this, the rusty bits. Now it's halfway between the diskette drive and the hard drive, so we have to find out where that comes from. And of course all of this needs a bit of a clean to to make it shiny. And we can see the date code here, 050890. So this PC was probably manufactured a bit later in the cycle. But what I'll do first, I'll take the power supply, open it up, and as you can see from the grill, it's quite dirty. And it could do with some TLC plus the fan. So that's the first thing I'll do. I'll show you a bit of that, and then we'll look at the floppy drive to see if anything is leaking, and then we'll have a look at the hard drive. And in the meantime, I'll also clean up the motherboard and clean everything, and then we'll see what we get. Here we have a power supply. You need a security bit to get those 6 screws off. Otherwise, you're struggling. And that allows you to take this cover off. At least I hope so. Ah, the power switch wants to come with it, or no? Ah, there we are. Yep. Oh, it's got a cable onto the board. And as you can see, it's a bit dirty. And I can't see, all the caps look okay. Of course, no reefers in here, I didn't expect that. But it would be worthwhile just cleaning this and maybe check the fan. I don't know if this is a 12-volt fan or a 240-volt fan. I think by this stage they use 12-volt fans. So let me get the fan out and I'll throw some air on this and see if we can clean it up a bit. Well, here's the power supply. After a bit of cleaning, I decided not to take out the fan. It's riveted in and it's too much effort. But a simple way to test it, because thankfully it is a 12-volt fan, is just to give it 12 volts and measure how much current it draws. So let's try that. And we'll also hear how noisy it is. And as you can hear, it's fairly quiet. And it's only drawing around 90 milliamperes, which indicates it should be fine, which is good. Now, I'm just wondering if I can power this on without any load, so let me check that. Okay, the power supply is here, hooked up to a 10 ohm load on the 5 volts. So let's power it on. And we can check the voltages again. That's our 5 volts. That's our minus 5 volts. This is our minus 12 volts and plus 12 volts. And I think that's the power good, which should be 5 volt. If the power supply is fine, it sends this signal to the motherboard called power good, which is used by the motherboard to reset the CPU. But everything seems to be in order here. So I'll just check if there's any filtering ripple on the 5 volts, minus 12 and plus 12 and minus 5. Okay, I've set it up to measure the ripple voltage on the plus 5 volts. So power on. And you can see it's pretty good. It's stabilizing, well, it's around 300-400 millivolt, which I think is fine. Let me see. Yeah, sort of around the 200 millivolt, which for plus 5 volt is fine. And here we have the plus 12 volts, 400 millivolt, no problems. Now this little scope is isolated from the ground, mains ground, so makes it a lot easier to measure these things. And here's the minus 12 volt, very similar, so I'm not worried about ripple on this power supply. And the last one are the minus 5 volts. Now bear in mind the minus 12, plus 12 and minus 5 are unloaded, so but it may increase slightly, but it should be fine. There's no indication of massive problems with this power supply. Good. All right, I'm back after having fixed up the power supply, and I've gone through the diskette drive. In fact, I have it over there ready to go. Cleaned up the PCB, and we're ready to power it on and see if it's still working or not. Because the last time I powered it on a few times, it was dead. But I don't think it would have changed a lot, but let's try. The diskette drive is not a tech model, it's YD701, I think. And it looks to be pretty well made. Bit dusty, as I said, but no surface mount capacitors in it. Well, there's nothing for it. Let's try to power it on. At least the fan is quiet as a mouse. And nothing. Sadly, it seems to be dead, so I'll have to look into that. I don't know what may have caused this to happen, but as you saw previously, it did power on with the 2401 error, which indicates the monitor or the motherboard. And then just after that, it simply refused to work. So let me have a look at it and see what's happening. Have a look at it, I certainly did. First, I made sure the voltages and ripple were all good while the power supply was connected to the motherboard and powered on. All the voltages measured fine and the ripple was even less than I measured before. I then took a closer look at the CPU in the socket. If you do a close inspection, I noticed that the connector pins in the socket looked black, not shiny as I would have expected. I took out the CPU and put the socket under a microscope. It was not a pretty picture, to say the least. The corrosion on the pins were pretty bad. They looked black. Now, after trying to clean the contacts with a fiber pen, I gave up and decided I would have to replace the socket. It's a PLC 68 socket, so I looked through my stash of cards and found a couple of AST CPU boards which had the same socket but with no chips in them. I removed both of them and chose the better one. I then had to be brave and tackle the removal of the socket from the IBM motherboard. I decided to use an infrared preheater to heat the board up to about 100 degrees Celsius and then used a desoldering gun to suck the solder off the legs. Thankfully, after a while the socket fell down, but I had to solder and desolder some of the pins more than once, especially the ground pins. As you see here, the right one is from the AST CPU board and looks a lot better than the original one. Now, after soldering the new socket into the motherboard, I inspected it under a microscope and found one trace was broken, which was my fault. One of the tracks was too close to one of the pins. I had to repeatedly solder and desolder, so I wasn't surprised. Anyway, easy fix. And then I put the CPU into the new socket and put everything back together again. Now, sadly, the motherboard was still dead. I was curious, so I checked the board with my thermal imaging camera while powered on, and I saw the CPU was heating up a bit. When it reached 65 degrees Celsius and was still climbing, I decided to turn the power off. Well, let me stop myself here. This episode is getting long in the tooth, so it's time to bring it to an end. But I promise there will be a sequel. But before I sign off, let me tell you what I've done and where I'm at. First of all, the PS2 here is still dead. Oddly enough, after I put in the new socket and I tried to power it on, as I said, didn't come on, dead. I left it overnight, came back in the morning and powered it on. And guess what? It fired up, but it had all these errors. I took a photo of the screen. I'll show you up here somewhere. This told me I haven't killed it yet, but the CPU became very hot very quickly, as I've shown you before. So I shut it down, tried to power it on again after it cooled down, and it doesn't want to play. So I suspect the CPU may have a problem. So I've ordered another CPU for it, and that will take time to get here. So hopefully I can show you what happens in the next episode. In order to progress though, I pressed into action the second Model 30. It has an identical motherboard, or planar as IBM called them. Why planar? Well, back in the day, all the computers had what they called a backplane, and the cards were plugged into them from the front, and the planar was actually vertical, or the backplane. And when IBM brought out the IBM PC with a planar being flat, or the backplane being horizontal, they decided to call it a planar. But today we call it a motherboard, so forgive me if I mix them up a bit. The other 286 machine has the same planar as this one, however it has a different CPU. Let me show you. This is the second Model 30 286 I'm using, or pressed into action. That seems to work, but as you can see, it's the same planar or motherboard as the other one, the first one, but it has a Kingston upgrade, so it's actually running a faster CPU in there. I think it's a 386SX SXL20. So I've taken out the memory to show you, but this one does work most of the time. Now that machine does fire up, but like this one before, it was failing the RAM sticks. And let's talk about the RAM. I've had no end of trouble with the memory that came in this machine. So I'll show you. Well, these are the 4 30-pin 512K SIMs that were in the first Model 30. And it counted after 1 meg, but then it started failing. So when I pressed the second PS2 Model 30 into action, I realized it didn't have any memory. And with these failing, it was a bit hard. So I went into my stash and I found these. These are standard 30-pin SIMs. And I did find on the internet, I'll link to it, how you can modify these to use in a PS30-286. And that's what I've done to two of them. You can see I've put some cut a couple of traces and put some cross wires. I put them in the second Model 30 and they work fine. These are 1 meg modules. I've got 2 more of these here. The others I haven't tried to modify. They're slightly different, and it just depends on how accessible the traces are on the back, how you can modify them. I found these were the easiest ones, and they work as 1 megs. Now with the 2 modified 1 meg sticks, I put them in that machine and it boots up quite happily. But when I booted up the first time, it had that monitor error as well, or graphics adapter or monitor error 2401. And I was scratching my head until I decided I'll bring out the big guns, brought out another IBM monitor, VGA monitor, and guess what? The 2401 error has disappeared completely. So no more 2401. However, this one did initially boot from the diskette drive, which seemed to be working. However, sadly, that diskette drive has a broken plastic piece. So I'll show you an overview of the diskette drives. And so you see where I'm at with those as well. So here are the 3 diskette drives from the 3 Model 30-286. They all have the same part number, but they're all different. The first one here comes from the machine I've been tinkering with, the YD701. The rotational speed is correct. I've tested it, as you can see, the reflector there. I've got one of these digital tachometers, which I can use to validate the speed. But when it comes to reading a diskette, it doesn't work. The second one has the same situation. It's a Mitsubishi drive, actually MF355C 599MA. It also runs at the right speed, but doesn't read any diskettes. The third one, which is a Mitsubishi one as well, is an MF355C, same as the other one, but 599MQ1. So it's a more complicated drive with some mechanism at the top to eject the diskette. This is the only one that worked initially, but that didn't last long because eventually I couldn't get a diskette out of it. And as you see, it's got a broken plastic piece there. I've tried epoxy, that didn't work. I tried superglue, that didn't work. So I'll probably use JB Weld next. Without any diskette drive, this is a bit hard, so I'm looking at using one of my other standard diskette drives and modifying the cable so I can do that. That's my next step. Yes, so it's time for me to wait for the new CPU for this one, modify one of my cables, the 34-pin flat ribbon cables to the 3.5-inch diskette drive, and use one of the more, or the later 3.5-inch diskette drives, which I have a few of, and see if I can get that one going. And then later when I get the CPU, I'll try that one. I'll also try the XT IDE card. I haven't tried that yet. So there's a fair bit to do, but thanks for persisting in this episode with fairly little progress, but hopefully in the next video I'll make more progress. And by the way, I have a third 286 as well, but it has the old planar, because these machines came out with two different planars, and the third Model 3286 has the old one, and it doesn't use a PLC socket. I'll show you a photo. It has a different type of motherboard and a different socket. I have not powered that one on yet, but hopefully in the next episode I'll have all three running. Yeah, it helps being optimistic. So for today, thanks for visiting the eCave. Until the next time.